Um, so should I get started whenever? Okay. Uh, well, there we go. Okay. So my name is Gabriel. I'm a researcher at Gensyn, and my background is in algorithmic game theory. I did my PhD studying essentially systems of agents interacting. How do we design systems for them? What will happen in these environments and these systems as they kind of interact and do weird things with one another, become adversarial, be very um, incentivized in their behavior. And when I say agent here, I mean it in the old school way, not in the I have an AI that's like using some tools and doing some stuff in some chain. I mean, something with real agency, just a very, very abstract term, something that makes decisions and behaves in an environment and is conscious of this and has its own objectives. Um, so today I'll be talking about basically using these markets to do this. Actually, this is an old version of my slides, so I'll add what I was going to say in the middle here now. But basically, uh, decision making is a bit unique when it comes to uh, machine learning tasks. I think we tend to forget that a lot of the times. And we treat decision making as something that is the same as question answering, classification, et cetera, et cetera. I think this is a mistake that we are not taking this into account. And we're hoping that something that is good at question answering and summarizing, et cetera, will be good at making decisions. That is not the case. I could talk about this for 10 minutes. I'm short on time, so I'm going to say it very quickly. But basically, in a traditional machine learning task, like what we typically use these things for, you have input that goes into the model that gives you an output. And often it's very easy to kind of know, is that good or not? I can just retry. The output does not affect the input. Therefore, I can just keep retrying with the same input until I get something good, perhaps. It's cheap to do so. I don't need to worry about something being strategic and how it's going to answer my math question, right? It's either right or it's wrong. Decision making is a bit different. Usually, you take in a world state, you make an action, and that changes the world state. So now I can't redo it most of the time, or at least I can't redo it easily. It fundamentally changes things. And this changes how we also have to kind of design machine learning algorithms. It changes how we should be approaching these sorts of problems. The other thing about decision making is it's often not myopic, where a lot of machine learning tasks are. I don't make one decision and then I'm like, cool, I'm done, I'm moving on. I have to make a decision thinking about 10 decisions going forward. And only at the very end of all of that does it come back. Decision making is also counterfactual. I can't know what would have happened. Well, sometimes I can. I can't know what would have happened if I'd done another decision, perhaps, especially when we chain these things together 10, 12, 20, infinite times, perhaps. So with that little preamble, like I said, I could talk about this for 10 minutes just on that. How do we make decisions? What's the way to frame this? Well, a typical way that we like to model this is that you have a set of experts that can just be data sources, sensors, or whatever. You take them in and you want to know, how do I kind of assign weights to these different things? And some very natural mechanisms people run into are what I have kind of behind me here. So on the most centralized, like obvious way of doing this, you have the dictator, right? One thing makes a decision, doesn't really matter. There's such a thing as weighting here. It's just whatever it chooses its decision is what you do. That seems to be the path we're on currently, where we just allow Claude to make all of the decisions. But is that the right way? I don't know. There's other things we can do along the way that moves all the way over to the most decentralized of them all. We can do things like committees. Here it's like a pre-selected committee. There might not be weights explicitly. They maybe debate, and at the end, do they converge on something? You can do an indirect democracy or representative democracy, where all the participants who want this decision to be made, they have a stake. They choose some representatives. Those people then become a committee, essentially, or they vote themselves. You could do a direct democracy, a liquid democracy. It goes on and on. It's very interesting, actually, when you look at these decision-making like mechanisms. But where I'm going to argue today is market mechanisms are probably the best option for a lot of collective decision-making tasks. And there's lots of reasons for this, but I think that the two that we probably converge on in this sort of space, where we want decentralization, we want to have this sort of incentives in play, would be this liquid democracy or the market mechanisms. I argue for the latter, mainly because, well, there we go. There's a lot of things that come to play with market mechanisms that aren't you don't have to worry about. They kind of give you a lot of for free properties that are nice. First of all, incentives. In a lot of voting structures, I need to basically give you a reason to participate, right? Unless you're very, very involved for some reason, you might not participate in voting mechanisms. With market mechanisms, You will, because you're incentivized financially to do so. You might do that, might participate in voting mechanisms for the same reason, but that comes to the next part here for the incentives, which is alpha in markets is the thing that drives the weights in the future. It's the way that we update things. You can have truthfulness in this because even if I go into a voting system with financial incentives, there's no way of calibrating, like, sort of, did you give me information because did you vote a certain way because it's going to later, like, you're an agent that thinks not myopically, right? Whereas in markets, you just are literally paying to be wrong in some sense. You can't manipulate in the same way that you could a voting system. The other thing that you get from markets is aggregation. Here, basically, prices are the thing that capture all the information. I don't need to give private information. I don't need to give evidence in the traditional sense of, like, here's my paper on why you should do the certain thing. I just manipulate prices a little bit. I say, hey, I think the probability of this action is too low, or I think if you were to buy, if I buy shares in this sort of action, it's going to maximize expectation. The other thing you get is a lot of freedom from what's called scoring rules. Again, 10 minutes on just scoring rules. So I'm going to move on from there. But you get a lot of free things, including, like, from the aggregation perspective here, basically everything is captured in prices. No one has to worry about anything else. I don't need to worry how much of an expert you are or kind of parse how you're trying to interact. It just comes for free. Selection is another thing that happens naturally here. This is what we call learning, right? And a lot of times, like, the people, it's something that's not known, but it's been studied for about 20 years now. Machine learning algorithms meant for online learning turn out to actually be provably equivalent to market mechanisms. And the reason for this is that you move capital around. Your capital serves as a sort of weight in the system. And you naturally start to have, after running this market over and over and over again, the weights converge on the people who are right the most. At first, maybe someone with a lot of capital can manipulate it, but over time, they will get drained unless they have infinite money somehow, right? So that's a nice thing. And then the last thing is that I think is the biggest boon for these sort of decentralized settings is the robustness, which is the thing that comes for free with markets, which is it's permissionless by design. I don't care if you're like, I don't need to worry about Sybil attacks. I don't need to worry about a lot of these things that are really messy in voting systems. You can pretend to be 100 different people. You have to split your capital 100 different ways, right? It kind of doesn't matter. Whereas in a voting system, I'd have to be like, how are you? How do I know you're the same voter? I don't want you to have 100 votes. So yeah, there's a lot of nice things here. The reason it became 4 is I wanted to make it 3 originally, so it felt nicer, but I couldn't stop myself. So how does this work? Let's get to like the brass tacks of it. Well, you'd have a trader. It can be a human or a bot. It's an agent. Doesn't really matter. And this person wants to go make a decision. They have some opinion. They have some information. So how do we do this? Oops, what's happening here? All right. Doesn't really matter. Anyway, so they want to make a decision. They somehow find themselves on a platform, let's say, that puts up all these markets for the decision making. They can peruse the decision metadata, which is like, which should we make policy X happen, or what will happen to some metric if I do policy X? Let's use that as a description here. What will happen to foot traffic to these businesses if I put up a bridge here? Let's say that's the decision we're making. This person comes in, this bot, this person, they have an opinion about this. They have information about it. They can go search the internet. They have the same information as everyone else. They can do research. That gives them an edge. They also might have private information that only they know. For example, they might know that the business that this bridge leads to just makes bad food. So it kind of doesn't matter if there's a bridge there. It won't increase the foot traffic to there because they have another problem. Anyhow, so when these types of mechanisms, what would happen is this person can take all this information, aggregate it. All they need to do is understand whether it's a wagering mechanism or a prediction market, how they want to interact with it. But TLDR is they basically have to come up with some prediction about how the decision will affect the system in the long run. They can affect the prices accordingly, and now that's all they have to do. They don't have to think about anything else. It's just that simple. Now, eventually you trigger a resolution oracle. So something that's going to say what the actual outcome is. So if this is the bridge example, we have to wait a bit. And then eventually I know, hey, it actually did or did not increase foot traffic, whatever however we're measuring this. And at the end of the day, the people who are the most right in the system, they're basically buying tokens saying that taking this decision is the right one. They can then exchange it back to make the money they made, because everything converges to 1 or 0 in most of these mechanisms. So being right again pays more. Like especially if you're right and almost everyone else is wrong, that's your best case here. And it really is pretty much that simple. And oh yeah, I forgot to mention, there's also a lot of traders. That tends to be helpful in these markets because you don't just want one person coming in and doing that. You probably won't profit very much if you're the only trader. Also, I don't know where I have to point this thing at this point. Here. Thank you. Um, so yeah, in conclusion, I'm probably running out of time. I'm not sure how long it's been, but this was the slide I meant to put earlier on, just so you know. But basically, decision making is not your typical machine learning task. You're gonna take anything from this talk. That's it. Like it is something special. And there's a lot of things that are really nuanced here. For example, the fact that it changes the environment. There's feedback loops. Often the world is adversarial, right? You're not just like, people have like they want a certain decision to be made because they have something else. 2 minutes, cool. And that's a very special environment. It's very different from what we see traditionally in machine learning. The other thing that's really interesting here is there's some really cool work happening right now showing that like a lot of alignment problems you can solve them in a few ways. One is you centralize everything to one one entity, and you say, I hope that person that entity aligns this machine learning algorithm or this model in a way that's consistent with me. The other is you put them all to compete with one another, and it turns out you can have emergent alignment. So I don't have time to talk about it too much now, but please do check out Aaron Roth's work on this. It's very cool. And then finally, yeah, it's just one thing that I know I'm sounding like a broken record if folks came earlier, but these things are tools, and we shouldn't be looking at them solve everything. Using markets for information aggregation or decision making is not appropriate for everything. It's appropriate for certain things that have to do like when the timescales are right. It can't be too fast. It can't be too slow. It has to be the right sort of thing so that you can actually get information to be aggregated in the system. You need to worry about the oracle design, right? At the end of the day, you're trying to predict what that resolution oracle will say, some degree. So if that's not good, you're predicting the wrong thing. You're trying to make the wrong decisions. The scoring rules matter. There's a lot of things that come into play here. And we need to be aware of that. Certain things like microsecond control, like of robotics, is probably not the right task for this sort of decision making. You need another type of mechanism. So, with that, yeah, I'll leave it there.